Search in a sorted 2D matrix. The problem is to find a given element in a sorted 2D matrix. Let's first understand what is meant by a sorted 2D matrix. We know what a 2D matrix is. A sorted 2D matrix is a matrix that satisfies two conditions. The element in each row must be arranged in ascending order, and the first element of each row must be smaller than the first element of the next row. This matrix satisfies both conditions. For example, elements of row 1, which are 1, 2, 3, 4, are in ascending order. Similarly, elements of the second row, which are 5, 6, 7, 8, are in ascending order. Also, the elements of the last row are arranged in ascending order. You can also check that this matrix satisfies the second condition. The first element of the first row, which is 1, is smaller than the first element of the second row, which is 5, and so on. I hope you understand what is a sorted matrix. Let's dive into the solution. A simple solution would be to go through all the elements one at a time. If we find a matching element, return true. If after going through all the elements, we don't find a matching element, we return false. The time complexity of the algorithm is equal to the number of elements in the matrix, which is n times m, where n is the number of rows and m is the number of columns. The space complexity is O1 since we are not using any additional data structure in our algorithm. Is a better solution possible? We know that we can find an element in a sorted array of size m in log m time. Since each row of our matrix is sorted, we can use binary search to look for the matching element in a row. In this algorithm, we first check whether the target element is in the range of the row. That is, the target element is greater than or equal to the minimum element of the row and less than or equal to the maximum element of the row, which is the last element of the row. If the target element lies in the range of the values stored in the row, we perform a binary search in the row. The time complexity is n plus log m because we go through n rows and we do at most one binary search. Let's discuss the optimal solution to this problem. The idea behind the algorithm is that a 2D sorted matrix can be considered as a sorted array of size n times m, and we can do binary search in a sorted array. To make it possible, we need to find a relation between the index of the 1D array and the 2D matrix. The index of the 1D array of size n times m will range from 0 to n times m minus 1. The element at index mid in the 1D array will be in row mid floor division m and at column mid modulus m. The rest of the algorithm is similar to the classic binary search. We check whether the element is equal to the target element. If yes, we return true. If it is not equal, we check whether it is less than the target element. If it is less, we look in the right half by changing low to mid plus 1. If the element is greater than the target element, then we should look in the left half by changing high to mid minus 1. If our while loop ends without returning true, it means the target element does not exist and we return false. The time complexity is log n times m because we are reducing the lookup region in half at each step. This is also equal to the time complexity of binary search. And the space complexity is O1 because we are not using any additional data structure.